What are operators in C++? Operators are special symbols that tell the computer to perform an action on values. A value is called an operand. The plus sign adds two operands. The minus sign subtracts them. Operators are the verbs of code. First, arithmetic operators. Plus adds, minus subtracts, star multiplies, slash divides. Percent gives the remainder. For example, 10% 3 equals 1 because 3 goes into 10 3 times and leaves 1 behind. Next, assignment operators. The single equals stores a value into a variable. Plus equals adds and stores. For example, x equals 5 puts 5 into x. Then x plus equals 2 makes x become 7. Comparison operators ask questions and return true or false. Double equals checks equal. Not equals checks different. Greater than and less than compare size. For example, 5 greater than 3 returns true. Logical operators combine true and false values and requires both sides true, or needs only one side true. Not flips the answer. For example, true and false returns false, but true or false returns true. Increment and decrement operators are shortcuts. Plus plus adds 1. Minus minus subtracts 1. For example, if count is 5, then count plus plus makes count 6. These shortcuts appear in almost every loop. Bitwise operators work on the binary bits inside a number. And, or, exclusive or, and shift operators flip and move bits directly. These are used for low-level tasks like flags, masks, and fast math. To recap, operators are the verbs of C++. Arithmetic does math. Assignment stores values. Comparison asks questions. Logical combines truth. Increment counts. Bitwise edits bits. Together, these operators build every expression you write. What is an arithmetic operator in C++? It is a symbol that tells the compiler to perform a math operation on numbers. The compiler reads the symbol, takes two values, and produces a result. C++ has 5 basic arithmetic operators: plus for addition, minus for subtraction, star for multiplication, slash for division, and percent for modulus, which gives the remainder. Addition adds two numbers. 10 plus 3 equals 13. Subtraction takes one from another. 10 minus 3 equals 7. These two operators work just like everyday math. Multiplication uses the star symbol. 4 times 5 equals 20. Division uses the slash. 20 divided by 4 equals 5. With integers, division drops the decimal and keeps only the whole number. The modulus operator uses the percent symbol. It returns the remainder after division. 10 modulus 3 equals 1 because 3 goes into 10 3 times with 1 left over. Modulus works only with integers. Here is a simple C++ example. Int a equals 10. Int b equals 3. Int sum equals a plus b. The variable sum now holds 13, ready to print or reuse. Operators follow precedence rules. Multiplication, division, and modulus run before addition and subtraction. So 2 plus 3 times 4 equals 14, not 20. Parentheses override the order when you need a different result. To recap, arithmetic operators in C++ are plus, minus, star, slash, and percent. They power every calculation, from simple sums to complex formulas. Master these 5 symbols, and you can write any math your program needs. Assignment operators in C++ store a value inside a variable. the equal sign takes the value on the right and places it into the box on the left. Here, x equals 10 means the number 10 lands inside the variable x. The simple assignment uses one equal sign. On the left sits the variable. On the right sits any value or expression. The value flows into the variable, replacing whatever was there before. Plus equals adds the right side to the variable. If x is 5, then x plus equals 3 makes x become 8. It is a short way to write x equals x plus 3. Minus equals subtracts the right side from the variable. Times equals multiplies the variable by the right side. Divide equals divides the variable by the right side. Each one updates the variable in place. Modulo equals stores the remainder after division. If x is 10 and you write x mod equals 3, then x becomes 1 because 10 divided by 3 leaves a remainder of 1. Bitwise assignment operators work on the binary bits of a variable. And equals, or equals, and XOR equals combine bits. Left shift equals and right shift equals move the bits sideways. Assignments can be chained. Writing A equals B equals C equals 0 sets all three variables to 0 at once. The value flows from the right and travels leftward through each variable. To recap, simple assignment stores a value. Compound assignments combine math with storage. Bitwise assignments edit bits. And chained assignments set many variables at once. These are the assignment operators in C++. Comparison operators in C++ take two values and return a simple answer, true or false. They live at the heart of every decision your program makes, from a small if statement to a long loop condition. C++ gives you 6 comparison operators: equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. Each one compares two values and returns a Boolean result. Equal to uses two equal signs. It asks, are these two values the same? If A is 5 and B is 5, then A equals B returns true. If B were 7, the same expression would return false. Not equal to uses an exclamation mark and an equal sign. It checks if two values are different. If A is 5 and B is 7, then A not equal B returns true. Use it when your program should act only when values differ. Greater than and less than compare size. If A is 10 and B is 3, then A greater than B returns true, and A less than B returns false. These operators are the backbone of sorting, ranking, and threshold checks. Greater than or equal and less than or equal include the boundary. If A is 5 and B is 5, then A greater than or equal B returns true. These operators are useful for age limits, score cutoffs, and inclusive ranges. A common bug is writing a single equal sign instead of two. A single equal sign assigns a value. Two equal signs compare values. Mixing them up creates silent bugs, so always double-check inside if conditions. Comparison operators return a Boolean, which flows into if statements, while loops, and logical operators. Together, they let your program make decisions, repeat work, and react to data. Master these 6, and you control program. In C++, increments and decrements are quick ways to change a number by 1. The increment operator adds 1. The decrement operator subtracts 1. You write them as plus plus or minus minus right next to a variable. Start with a variable x equal to 5. After x plus plus, x becomes 6. After x minus minus, x goes back to 5. Each operator changes the variable by exactly one step. There are two forms. Prefix puts the operator before the variable, like plus plus x. Postfix puts it after, like x plus plus. Both change x by 1, but they differ in when the change is used. Prefix increment updates first, then returns the new value. Let x equal 5. The line y equals plus plus x makes x become 6, and y also becomes 6. The update happens before y reads it. Postfix increment returns the old value first, then updates. Let x equal 5. The line y equals x plus plus makes y become 5, and x becomes 6. Y sees the old value, while x quietly moves up. Decrement works the same way. Prefix minus minus x lowers x first, then returns it. Postfix x minus minus returns the old value, then lowers x. Start with x equal to 5 and watch x slide down to 4. These operators shine in loops. A for loop uses I++ to step through items one by one. A while loop can use count minus minus to count down to 0. Each pass quietly changes the variable. So remember, plus plus adds 1. Minus minus subtracts 1. Prefix updates before use. Postfix updates after use. Pick the form that matches the value you want right now, and your C++ code stays clean and clear. In C++, operators help us make decisions and manipulate data. Two important groups are logical operators and bitwise operators. Logical operators work on true and false values. Bitwise operators work directly on the bits inside numbers. Logical operators come in 3 types: and, written as double ampersand, or, written as double pipe, not, written as exclamation mark. They combine Boolean conditions to produce a single true or false result. Here is how and or behave. And returns true only when both sides are true. Or returns true when at least one side is true. If either condition fails for and, the result is false. The not operator flips a value. If the condition is true, not makes it false. If the condition is false, not makes it true. We use this to check the opposite of a condition in our code. Now, bitwise operators. These look at each bit of a number. The main ones are and, with single ampersand, or, with single pipe, XOR, with caret, and not, with tilde. Each compares bits position by position. Let us see bitwise and or in action. Take 1010 and 1100. Bitwise and keeps a 1 only where both bits are 1, giving 1000. Bitwise OR gives a 1 if either bit is 1, giving 1110. Bitwise XOR returns 1 when bits differ. Bitwise NOT flips every bit. We also have shift operators. Left shift moves bits left, doubling the number. Right shift moves bits right, halving the number. So remember the key difference. Logical operators decide true or false for whole conditions. Bitwise operators work on individual bits inside numbers. Use logical for control flow and bitwise for low-level data manipulation.